Okay, in today's video lesson, we're going to continue yesterday's lesson, section 6.5 in the text, solving rational equations. Today, what I'd like to do is solve three of the more complicated types of rational equations. And what I'd like you to do is take a minute and copy down these three problems and then solve them on your own. So you need to pause the video now, copy the problems, and solve them. Once you have the problem solved, then continue the video as we're going to work through the problems together. Okay, so example one. In example one, remember the first thing we need to do is find our domain restrictions. Before we can do that, we need to factor our denominators. So the first fraction is going to factor to 2x times x, and then 1 times 2, and it's going to be a positive 2 and a negative 1, minus 1 over 2x equals 3 over x times x plus 2. All right, domain restrictions. Let's talk about that first. So our restrictions, list them as your restrictions, and we look at each factor. 2x minus 1 cannot equal 0, means that x cannot equal 1/2. X plus 2 cannot equal 0, means x cannot equal negative 2. And for these two, we know that x cannot equal 0. And x plus 2 is the same here. All right, so there's our domain restrictions. And next thing we want to do is solve this rational equation. I'm going to use the clearing the fractions or the LCD method. So I need to find my LCD. I look at all the factors in my denominator. So I need to include in my LCD the 2 and the x. I need to include the x plus 2. And I need to include the 2x minus 1. And then once I determine that LCD, I'm going to multiply both sides of the equation by that LCD in order to clear my fractions. So I'm going to multiply both terms here, and the only term on the right will also get multiplied by the LCD. All right, so let's look at what happens here. I'm going to distribute to the first term, and in that first term, I can see that the x plus 2 and the 2x minus 1 will both cancel, leaving me with 2x times x. So my first fraction, the denominator cancels out, and I'm left with 2x times x, or 2x squared. Then I'm going to multiply the LCD times the second term, so I have the minus, the 2x's cancel out, and I'm left with x plus 2 times 2x minus 1. On the right side, the x cancels out, the x plus 2 cancels out, and I have 3 times 2 times 2x minus 1. All right, let's clean this up. 2x squared minus, so distribute this, 2x squared plus 3x minus 2 equals 6 times 2x minus 1. Combine like terms here, let's distribute the negative. 2x squared minus 2x squared minus 3x plus 2 equals 12x minus 6. Simplify and solve. So I add the 3x and then add the 6, and I get x equals 8 over 15. I can include this in my solution set since it is not one of my restrictions. Moving on to, example 2. So again, we need to start by finding my LCD, by factoring my denominator so that I can find my domain restrictions. So it's only that second fraction that needs to be factored, and it factors to 2x times x minus 5. All right, so as far as restrictions go, for this factor, x minus 5, I know that x cannot equal 5. And for this factor, I know that x cannot equal 0. So here are my domain restrictions. Next, I'm going to clear the fractions using the LCD method. So my LCD, I need to include the x minus 5 and the x. So my LCD is just x times x minus 5. Multiply both sides of the equation by x times x minus 5. So on the left, I get 3x times x minus 5 equals, distribute on the right to both terms. So in that first fraction, the x minus 5 will cancel, and I'm left with just the x times 1. So I get x minus, and here the whole denominator will cancel, so it's just x minus 2. Clean this up. 3x squared minus 15x equals x minus 2. Set equal to 0. 3x squared minus 16x plus 2 equals 0. And it doesn't look like this will factor. So what do we have to do? We have to use the quadratic formula. A equals 3, B equals negative 16, and C equals 2, which means that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 16 plus or minus the square root of 256 minus 12 times 2 is 24 all over 6. 16 plus or minus 256 minus 24 is 232. 232 is divisible by 4, so it's going to be 4 root 4 times root 53? No, 58. And 58 is only divisible by 2 and 29, so it does not simplify further. And I get 16 plus or minus 2 root 58 over 6. And these terms here can all be divided by 2, so you need to simplify one step further. And my final answer, I'm going to write it up here because I ran out of room. My final answer is divide each of those terms by 2, and I get 8 plus or minus root 58 over 3. That's not one of my domain restrictions, so that works for a solution. And then my final example here, let's convert these to fractions. P to the negative 2 is 1 over p to the positive 2, plus the 4 remains in the numerator because it's not part of the base, but the p to the positive 1 power moves to the bottom, minus 5 equals 0. All right, we begin again. Once we have it in rational form, let's look at our domain restrictions. In both cases here, our restriction is that p cannot equal 0. All right, so clear the fractions using the LCD method. So my LCD is going to be p squared, and I'm going to multiply everything on the left by p squared and everything on the right by p squared. Distribute to each term. P squared times 1 over p squared is just 1. P squared times 4 over p is going to be 4p. P squared times 5 is minus 5p squared equals 0. Multiply through by negative 1. 5p squared minus 4p minus 1 equals 0. And then factor. 5p and p give me 5p squared, and 1 give me 1. I need one of those to be negative, so I want my negative 5p to be negative, and then plus p. All right, so solve each of these. I get p equals negative 1/5 here, or p equals 1. And again, those are not restricted from my domain, which means they are both possible solutions. That's it for today. Have a good one.